Okay. Hello, everyone. Can anyone on the call confirm me if you can able to hear me? You can type in the chat window. Is a screen share blurry? Okay. Thanks for confirming. We'll get started in a few minutes. We'll wait for other folks to join. This is supposed to start in like 3 or 4 minutes from now. So, few introductions before we start. You can post your questions in the chat window if you have any. So feel free. I'll be looking at the chat on a side window. So feel free to post your questions while we do the presentation and also the demo. So feel free. Okay. So while we wait for other folks to join, I would encourage you to put in some information about you in the chat window. What exactly, what kind of role you are in, whether you are from dev or from ops. So that will help me fine tune the content during my presentation and then demo. Just put like your name. Obviously, it has already your name. Just put your kind of role, like are you from dev or ops, and are you familiar with Docker and Kubernetes at all. So just put 2 words. That should be good. Thanks for posting your information, Saideep. Looks like you're getting started with Kubernetes and containers in general. Okay. Okay, Kiran. Okay. So we are the top of the. I mean, we're almost. It's time to get started on this presentation. I want to give 1 more minute for further folks for the a few more people to join. Hey, Metis. Yeah, I've heard of GitHub Cloud. Uh, thanks for joining. Okay, cool. So I'm hopefully this will be like a basic, very touching on the basics of why exactly we need Kubernetes and OpenShift, and then Docker in general. But if you have any advanced questions, feel free to post in the chat, and I'll take it at the end of the presentation. So with that, let's get started. My name is Chakradhara Jonagam. You can call me Chak or Chakri, whatever you want. It's pretty open. Uh, I'm a solution architect specialized in OpenShift. I also worked on a couple of other orchestration tools like Mesos and then Docker Swarm before. I ended up on OpenShift. I'm also a CNCF ambassador. If you're aware of Cloud Native Compute Foundation, uh, it's a part of Linux Foundation that looks at cloud native applications, mostly running on in a cloud native way. Um, so I'm a CNCF ambassador as well. That's a background about me. In past, I used to be a developer, and then I turned up mostly on the container side from last 2.5 years. So that's a bit of background about me. And then we'll see what exactly we are going to cover in this session. We are going to touch base on Kubernetes, OpenShift, and then Docker, very high level. I will not go like deep into the what exactly is a container, because most of you folks, I'm guessing you might be already knowing that. But I'll just give like one liner of what are those. So what exactly is OpenShift, and then what exactly is Kubernetes? We'll try to understand. Okay. So what exactly is OpenShift? Uh, you may call it as platform as a service, but this used to be a thing of past. It's more than platform as a service. Platform as a service is like one part of it, but it can do many other things as well. So I'm gonna discuss that. You can call it as a container orchestration. So if you have containers, if you're running applications as containers, and if you want to run them across multiple machines or thousands of machines, you need some kind of orchestration. So OpenShift or Kubernetes is basically a container orchestration tool as well. And then I would say OpenShift is like a enterprise ready Kubernetes. Uh, like let's say if you have already familiar with Kubernetes, Kubernetes helps you run containers across multiple nodes, right? But to make it like truly enterprise ready, it needs some more other tools around Kubernetes to make it like truly enterprise ready. So it may be logging, it may be security, it may be monitoring, it can be a developer lifecycle, the developer workflow. So there are a lot of other things that you need on top of Kubernetes to make it enterprise ready. So OpenShift is your Kubernetes plus some other awesomeness, like which you need to make it enterprise ready. So that's what OpenShift is all about. Okay. So give you we are going to discuss three things today. One is Docker, Kubernetes, and then the other one is OpenShift. Okay. So what exactly these are? Think of Docker as this is an analogy that helps you understand what exactly it is. So Docker is like uh, is like a Docker image is basically like a class for your application. Okay. So instead of you may have many classes in your application, but think of this is just an analogy. Think of representing a class for your application. That's what your Docker image is. Whereas container is basically an instance of that class. So it's like a running instance of your application, or Docker image is called container. Okay. So what exactly is Kubernetes then? Think of Kubernetes as your kernel for your entire data center. Okay, so if you have like let's say 1,000 machines in your data center, Kubernetes is like your kernel for your entire data center. Why I call it as kernel for your entire data center, I'm going to give the in detailed approach like in the next few slides. But think of the analogy that for your whole data center, you have one single kernel that's basically Kubernetes. Okay, and then OpenShift is like your operating system for your entire data center. Okay, underlying, it uses Kubernetes to do most of the activities, but OpenShift adds all other features that are necessary to make it like a more like a operating system, okay, for your data center. So this is just an analogy. This is not like literal meaning of these things, but just to give you an overall view of what exactly we are discussing. This is what I came up with, like to make it understand for everyone. This is what I came up with. So Docker is like your refers your application. Kubernetes refers your data center kernel for your data center, whereas OpenShift refers like a operating system for your data center. Okay, just to give you a quick understanding of what exactly these are. So moving on, you might have heard this a lot, right? Like, but it works on my machine. This is like a daily conversation between dev and ops, or in between dev. So because uh, when developers give things to operations, this is what they see, right? When it works on my machine, it should be working on maybe on QA, maybe on perf, maybe on testing, and maybe on production as well. So it works on a machine, and it's supposed to work on your machine too, because I've tested it on mine, right? So, but what really happens when it goes to operations is this, right? Like when they see stuff from dev, this is what they see. Okay, it doesn't work on their environment. Okay, this is not essentially a fault of dev or ops. This the fundamental problem is here. So when you develop things using the traditional way, yeah, maybe you are developing on Windows. Maybe you have like middleware version as version 1, and maybe you have different runtimes along with that. So this is like your dev environment. Whereas in QA, the things might be different. Like it may be running on Amazon, it may be running on VMware. So, and the middleware version may be different, right? So uh, things are very different when you go with a one environment from dev to QA, or from QA to prod, when you go with a traditional approach that we do now, because the versions differ, various co-locating applications differ. So a lot of things you need to take care when you move applications from one environment to another environment. So this is like the fundamental issue. So, but to address this issue, what if I can package my entire operating system, middleware, and then my application together as one single immutable image? So what I mean to say is, currently the transportable unit that you give to operations or any other when you share your application, you share your var file or maybe the artifact that you have for your application, right? But whereas in the Docker based environment, I want to give uh, all these things in one go, which is basically your operating system, your middleware, and your var file as one single binary, so that when things move, they move like one single binary. Okay, so that the chance of breaking things when you move in the second way is very less compared to the uh, traditional way of delivering a var file or delivering a artifact. Okay, it is applicable to any language, not just Java, but any language. If you are delivering in this mode, the chance of breaking things might be more when compared to packaging all your operating system, middleware, and var file as one single immutable image. Okay, so that's what addresses the issue. Okay, and then uh, and then think of treating each process on your operating system as almost like not equal to VM, but you get all kinds of isolations. Like it has its own IP address, it has its own network, it has its own file system, and everything as like as though it is just a process on the operating system. It feels like it has all the features, almost all the features, like a virtual environment, right? So uh, the benefits are tremendous because you're avoiding that entire operating system overhead of that operating system in the VM, right? You're basically treating each process as like isolated applications, and you get all the features of almost like all the features of a VM. So You get that isolation with the benefit of just processes instead of VMs. Okay, so this is what Docker does. So it basically helps you package your application as binary image, and also gives you the isolation at the process level. Okay, so two things basically help you containerize your application and then run them as processes on your operating system. So this is what Docker does. And also the isolation of process that I discussed is there from long time. It's been there from like 15, 20 years, I guess. So it's used in many companies. Maybe in like Google has been using it for a long time. Red Hat has been using it for a long time. But what Docker has done is bring those advanced technologies like the container technologies to masses. Okay, so even a developer can basically convert your application to a container. Not just the geeks, but also developers can convert. So this is that the packaging system is what Docker has done. Okay, so when you move application into containerized mode, this is what you get. So you have got like the consistent environment across dev, QA, and prod, because uh, apps run as Docker containers, so they are isolated, so they have everything they need. So they don't need to depend on the other existing like libraries of the other applications at all. Okay, so it becomes consistent, and the predictability of moving from dev to QA, it becomes more easy to move things, and then few of the developer problems will be addressed. Okay, and also operational aspects as well. Okay, so with that, I'm going to give a quick halt and then see if we have any questions. Okay, I'm looking at the questions. Okay, so it looks like we don't have many questions. Let's move on. So I'm going to jump into the demo piece. This will not be like pure slides at all. Slides are only a short version of it. But let's go and deploy something and see in real time. Okay. So now we are going to see the demo aspects of my presentation. So I'll switch roles between dev and ops. Okay, so for some time I will be dev, and then for some time I will be operations, and then let's see what is the kind of role for dev, and then what's the kind of activities that operations does. Okay, so let's assume that I'm in operations for a few minutes. I need to allocate some memory, CPU, like the resources for dev to be able to deploy applications and run them. Okay, so as an operations, I come into the OpenShift platform, and then I go to new project, and then create namespaces or projects or the teams here in the OpenShift container platform. So I call it maybe dev team or maybe dev one team or whatever name you want. This is just a logical isolation. Okay, and then hit create. Okay, and now I got dev namespace here. Okay, and then I can assign developers to this particular namespace by clicking on this and then adding more users. Okay, for the sake of simplicity, I'm going to be everything like dev and operations both, but you can go and add it from here. And then I'll create a QA project. Okay, so my QA project is also created. So I can assign all the developer users to this namespace, and also all the QA users to this namespace. So I'll switch my role and then move as like a switch my role to developer now. So I'm a developer now, and then I'm logged into my developer namespace, and then I'm going to deploy an application. Okay, it can be Java application, it can be Node.js application. I've seen people deploying like C++ applications also. It's not really restricted. Okay, so click on add to project, and then you can see different like runtimes for languages. So Java, Node.js, .NET, PHP, Perl, Python, Ruby. You can have your own like C++ maybe, or whatever you want on this. As long as it runs on Linux, that's what it needs. Okay, and maybe in future Windows as well. Um, and also different databases. Like if I go into data stores, you can see different databases. You can see look for MySQL, um, MariaDB, a lot of other databases as well. So you can see MySQL here, and also MongoDB as well. Okay, so that's the language stack or the support you have. But for us, for our demo, let's go and deploy a Node.js application. Okay, so I have a Node.js application here, pretty general Node.js application, nothing specific to OpenShift at all. What we're going to do is, as a developer, let's see how easy it is to deploy applications onto this platform. Okay, so what is there in for developers, and what is there in for operations to on OpenShift container platform? How does OpenShift make their jobs easy? Okay, so as a developer, I have a Node.js application. I want to deploy it and then run it, and then maybe scale it for a few instances, and how all that goes in. Let's look at that. Okay, so as a developer, I have a simple Node.js application. This can be a complex one as well, but nothing specific to OpenShift at all. So what this application does is, it basically, when you hit the root endpoint, it says hello world and the version and the host name on which it is running. And there's a health endpoint which basically tells whether the application is healthy or not based on a Boolean value. In real world, you won't have this, but just for the sake of demo, I'm putting like a Boolean value, and then whether this is healthy or not by looking at the Boolean value. Okay, if I hit a endpoint called cancer, this is going to make the application unhealthy. Why I have this endpoint is because I want to test the resiliency of the platform in the future demo. That's why I kept this endpoint. Um, but this is like a general Node.js application. Okay, and this can be a Java application as well. It doesn't really matter. Okay, so I'm going to take this Node.js application, and then as a developer, um, in the old way, or maybe the way how we do it now, is basically we have to go to operations and then ask them for some resources, like I need a machine with all the goodness of security that you have, and then this much resources, and all these things you need to basically communicate with operations. And then typically anywhere between 2 weeks to 1 month you will get that resource. Okay, but whereas in OpenShift, you basically do it like a self-service. All you do is go log into the OpenShift console, and then provision your environment, like your Node.js environment. Okay, and then maybe a specific version of Node.js environment, and then give your source code URL. That's it. Okay, and then maybe name your application like welcome or something. So all you're doing is you're doing a self provision. As a developer, I just go into the platform and then self provision my environment. So I have my application name and then my source code where exactly it is. I can also put some constraints like CPU usage, memory usage, how much this should consume and everything. But I'm going to leave it to default and then hit create. That's it. And then you can see now OpenShift is doing a build activity. So if we go click on view log, you can see it is cloning the source code, looking at the package.json file. If it is a Java application, it looks at pom.xml file, and then installs all the dependencies, converts into a Docker image without you having to write any Docker file at all. Okay, so you can see it is converted into a Docker image, and now it is pushed into the internal OpenShift registry. You can see it is now currently pushing. So OpenShift comes along with a inbuilt Docker registry as well. So you don't need to like integrate any other registry. It can also talk to external registries, but if you want to have like on-prem registry, you can totally do it with OpenShift. Okay, so you can see now it is converted into Docker image, and now it is pushed, and it's almost like 99% complete, and push is complete now. If you go take a look here, the image that you built will be deployed. It will be pulled onto one of the machines, and then it will be deployed. Okay, now you can see my application got deployed. It should be ready to go. So if I click on this, you can see my application is up and running. Okay, so pretty fast for developers. Like developer doesn't need to worry about provisioning those environments, like you need to communicate with operations, do all those provisioning process. So all that is taken down from anywhere from 2 weeks or 4 weeks time to literally few minutes or seconds. Okay, so my application is running, and where exactly is this is running? So let's go and take a look. I'm going to log into the CLI. Let's make it bigger. So I'm logging into the OpenShift console using OpenShift using a CLI. Okay, so if I do OC get nodes, that shows me number of nodes in my cluster. So I have a cluster of machines which are basically like 3 worker nodes, and then 1 infrastructure node, and then 1 master node. Okay, so my application will go anywhere on these 3 nodes, or maybe on the infra node. Okay, so um, you basically told OpenShift that go and deploy this particular application. Where it deploys, it's not your problem. Like it's not developer problem, right? It basically chooses one of the available nodes in the cluster, one of the available nodes which has resources on it, and then goes and deploys it. So no longer you have to worry about individual machines. You only basically worry about the cluster, but not like individual machines. Okay, so this particular application got deployed on node 3. Okay, I did not tell OpenShift to deploy on node 3. Based on the current availability, OpenShift has chosen that node, and then it deploys. Okay, now I want to scale this application to maybe 3 or 4. How do I do it? I just hit that button, and then my application gets scaled pretty quickly. Okay, so it's easy to scale your application as well. With few clicks or less than a minute, you are able to scale your application as well. Okay, so I'm looking if we have any questions on the chat. Looks like okay. So can we download that container and run it on my local environments or other servers with Docker running there? Definitely you can. So when you build this application, OpenShift comes with a registry, right? I said it comes with a registry as well. So if I go click on this registry console and log in, you will see that image there. Okay. Let me log into that. I'll show you where exactly you can take a look and then download it on your machine. So all these machines are basically okay. My URL is not configured properly, but these Docker images that are created by OpenShift are pure Docker images. So you can download them and then run it on pure Docker daemon. Totally like fine. It's not really anything specific to OpenShift at all. Okay. So moving on, I'm able to scale my application as well pretty quickly. Like you can see, let's go and see if it is really scaling it or not. So I'm gonna write a small script that pulls on that endpoint, sleep for maybe 0.5 seconds. Now you can see every time it responds, it is responding with a different host name on it, right? So that means my application is really getting like scaled and also load balanced automatically. Think of that before think of that doing before you have like in the traditional way you have to you have to put a HA proxy or some load balancer in front, and then do a lot of manual scripting to basically uh, do all this load balancing piece. Whereas now it's like almost instantaneous, right? Like you just scale it up and everything is taken care for you. Okay. uh, so where can I find registry console? I mean the image to run on my cluster. So the registry console is by default installed in the default namespace. When you install OpenShift, it also comes with a registry console installation as well when you choose the advanced install. So you click on this and then that will show the registry console in the default namespace. The short answer is in the default namespace. Somehow okay, now it turned up. Looks like there's temporary there's a URL redirect for my domain name, so it's always going to the other one. But if you have the right URL configured, it's basically going to show up the registry console, and then it also shows you how to log into the Docker registry of OpenShift, and also how to push and pull images from the Docker registry of OpenShift. Okay. So this is a Docker registry, and this registry console is basically a UI for this Docker registry. Okay, and this is basically your router. Everything is running as a container in OpenShift. Even your other infrastructure components will run as containers. Okay. So now, as a developer, I'm able to deploy my application in pretty quick, less like in minutes rather than weeks, and also scale my application pretty quickly. And you can see my application is consuming about 65 megabytes of memory, and then some network 0.3 kilobytes per second network, and then there is zero load on it, like almost nothing, because I'm just hitting it for 0.5 seconds. So this is how as a developer, I can deploy. But what if I want to update this application? Okay, what if I want to do some changes on this application, because this is getting pretty popular? I need to do some changes and then redeploy. How quick it is for developers to redeploy this? Okay, the current version is v1.8. Let's see, I want to deploy a 1.9 version which has more awesome features. Okay, just assume that I can just go to builds, select the application, click on configuration, and then select the GitHub webhook URL. And then in GitHub, I can go to settings and then webhooks, and then set up that webhook here. Okay, it asks for password, and then set up that, and then choose the application JSON here, and then disable SSL because my certificates are self-signed, and then add webhook here. Okay, so the basic pipeline is set up. When I make a change and then push it to GitHub, it automatically goes and deploys inside my OpenShift cluster. So how does it do? Let's go and see. Okay, I want to change my version from v1.9 to v1.8 to v1.9. Okay, so I changed and then pushed that, and then immediately you can see a new build is happening here. Okay, a new build is happening, and once the build is complete and once the image is ready, it is going to redeploy your application. You can fasten your builds by using incremental builds. By default, it just does everything from scratch, but you can basically do incremental builds as well. Okay, so give it a couple of seconds, and we should be able to see you can see our image is completely done, and then it is getting deployed on a machine. So you can see a new version is coming up on my other machine, and the old version is taken out. New version is coming up here, and the old version is taken out. So intermittently, you can see 1.9 and 1.8 running on my front-end traffic. You can see everything is now on v1.9. Okay, give it a few seconds and you can see everything is now on 1.9. Okay, so as an operations, as a developer, there is no longer a friction between developer and operations, because it's pretty easy to move your things around between, like it's easy to deploy a newer version of applications pretty quickly. So there is a lot less friction between developer and operations. Uh, so the question is this available only on enterprise or origin as well? So this is all available on origin. So it's basically whatever I'm discussing now is also applicable for origin as well. So there is nothing in the feature list that works on enterprise but not on origin. So everything that you see on the enterprise, you will see it on origin as well. Okay, so so for the folks who might not know what origin is, basically OpenShift Origin is a open source version of OpenShift Enterprise. So it's like completely the source code is on GitHub. You can go and build on your own. So that's totally there. So whatever I discussed today is completely open source. Okay. All right. Cool. So my application is totally now moved to 1.9 version. You can see it on the traffic on the right side. Okay. Now, what I want to see, what I want to do as an operations is, or and as a developer, I want to attach some storage to this. Okay. How can I attach a storage to this particular application? It's pretty easy. All I, as a developer, again, I don't need to go to a lot of teams to provision storage. Operations will already provision storage and attach it to OpenShift cluster. As a developer, I just go to click on storage and then say create storage here, and then I have my storage. Okay, so create storage, and then you have different types of storage you can choose. NFS, cluster, iSCSI, Ceph, you name it. There are a lot many storages. Okay. Let's say my storage one for this, I will use it for some purpose. Okay. I just name it. I'm provisioning the storage first, and then I attach my storage to some application. Okay. I can provision the storage in multiple modes: single user, or shared, like read write access, or just read only. But I'm going to pick the read write multiple, and then let's say I want to provision like 6 gigabytes of storage. Okay, and then save this. So what OpenShift does underlying is basically go and provision storage on. In this case, I have chosen Gluster. I hope I have configured Gluster on this cluster. Yeah, I think it is configured. So you can see my storage is provisioned on a Gluster backed storage, but it can be NFS, it can be like host path also. There are a lot of options there. So my storage is configured now. Like I have a 6 gigabytes of storage. I can use this storage for any application. Okay, let's see. I want to use that storage for this application. Okay, my welcome application. I just need to go to deployment config and then click on configuration. And then there is a button at the bottom, add storage. Click on that. And then if it is only one, it is going to select automatically my storage, or you can choose your own. And then mount this storage, whatever you have provisioned, at this particular location or whatever location that you want. Okay, so I have selected here. You can also choose a subpath. You can give it a name and then everything, and then hit create, like add. Okay, so that storage will be mounted to my welcome application at that whatever location I wanted, like /data location, right? So it's easy to provision storage as a developer as well, not just like applications, but also for storage as well. It's pretty easy. Okay, so what this means is, it also means you can not only run your microservice application, which doesn't really have a lot of storage. You can also back it with like a person storage, so you can run your traditional Java applications which require some kind of storage as well. Okay, All right, so you can see my storage is there now, and then I can choose any instances and then go and click on terminal here, so that you will go inside that particular application, and then you can switch to /data, and then let's create some application, like some content here. Okay, just to test it, I'm going to say hello OpenShift, and then save this. Okay, now I have saved a file inside the /data section. So if you are aware of containers, containers are ephemeral, right? Like if I take down all the containers to 0 and then bring them back, all the storage that you have will be gone if you did not configure any persistent storage, just like I've done. Okay, so but since we have backed it with the persistent storage, which is again backed by cluster, you should see that whatever file that we created should be already there. Okay, all right. No, I'm not drinking any coffee or tea. Is the audio okay with everyone, or are you facing any issues? You can just put in the chat if you want. Okay, cool. So once I scale it back up, we should see that whatever storage that we had at that particular location, which is basically /data, we have that already there. You can see our data is persistence there, even though we had our container, we have scaled the containers down to 0 and backed it up to 1. Our storage is still there. Okay, so underlying it is basically using Kubernetes. Like OpenShift is using Kubernetes under the hood, but it is adding a lot of other features like UI, and then also storage, different kind of storage, and security, a lot of other features on top of Kubernetes to make it like truly enterprise ready. Okay, I'll stop for a second and see if you have any questions. Okay, cool. So we have seen how to deploy a application using source code, right? But OpenShift not only supports source code to Docker image conversion, but if you have a Docker image somewhere already created, it can basically run the Docker image as a container. So how do I do that? You just go to add to project and deploy image, and then you can select deploy image. I have a Docker image on Docker Hub, which is basically like a Go application, pretty similar to what you have seen here. And then I can deploy that, and then say instead of new welcome, Go welcome, I'm gonna say new welcome. This is like a newer version of my application. Let's assume that. So not only from source code, you can also directly import your Docker images. If you have already done some Docker images creation outside OpenShift cluster, you can basically import them and then deploy them just like you do for traditional applications as well. So you can either start from Docker image, or you can start from Docker file, or you can start from source code. It's not really restricted in any way. You can actually start from a war file or a jar file too. Okay, not just these three. So my application got deployed. I can create a route, and my application is up and running now. Okay, so this is same application but written in Go, which has like quite something similar, like similar output, but with a different version. Okay, now I can also deploy my Docker images as well. Okay, so you can see my application is still running, right? So what I want to do is show you some cool features what OpenShift adds on top of Kubernetes. Okay, so as a Kubernetes user, you may not be familiar with these URL things, right? Like this is actually created by OpenShift and automatically, like this is basically using HA proxy in front, and also it can talk to F5 to update the rules and provisions these URLs automatically. Okay, and that's not the coolest feature, I guess. So you can do more than that. What if I want to split traffic between my older version of my application and my newer version of my application? Can I do that? You can pretty much do it. So this is my live URL, right? This is like my production URL. I go to my production URL, which is this one, and then click on Actions, Edit, and then split traffic across multiple services. I can select my newer version and my older version, and then choose the amount of traffic, like 30%, 16%, like 50-50, something like that, and then save this. And then your traffic will be split like 50% across your services. Okay, so you can see this version is running using about 7.2 megabytes, and this version is using about 63 megabytes because it's written in Node.js. This is written in Go, so there's a lot of difference there. But it's pretty easy to split your traffic as well. Okay, there is one more step that you need to run to make it work. I haven't done that piece, but if you have done that, it basically shows like 50% traffic here. Okay, but it's as easy as like splitting traffic like this. Okay, looking at the questions, I have a cluster on GC and trying to make app from source to GitHub and got an error. So I'm guessing that's because of the connection issues. We can take a look. Like if this is looks like the firewall is not restricting you to go to GitHub. Check if your GC cluster is able to talk to GitHub or not. I think that's the issue I see there. Okay, so it's pretty easy to do some manipulations on the incoming traffic as well. If you haven't heard of Istio, there is one more project coming in. It's pretty like getting famous now. Take a look. This is basically does some advanced traffic routing, which are needed for microservices. But it's pretty easy to do the basic stuff inside OpenShift as well. Okay. Now we have seen my application went back. You can also roll back if you want by clicking on deployment config, and then there are different history. You'll show all the history here, and you can go pick a specific version and roll back to that particular version by selecting a rollback button. If you have more, it will show you rollback button there. Okay, so it's pretty easy to deploy and also roll back your applications. So what if I want some kind of database for my application? As a developer, I want some database, obviously, for my application, right? So by default, OpenShift supports a number of databases, both SQL and MySQL. If you look at data stores here, I'll go and deploy, let's say, MySQL. Okay, MySQL data, so it's MySQL FML, and then select that, and then it automatically generates some username and password for me. So these are the username and password for the database I can use in my application, and then I should see MySQL getting deployed. So you can see it is now pulling the Docker image of MySQL and then getting deploying it. So as a developer, it's pretty easy for me to provision environments. So it brings it takes out a lot of manual work out of the whole process. So it's very productive for developers and also for operations as well. So operations can just focus on keeping the cluster alive, whereas developers can do productive work on their own. Okay, so now it is deploying MySQL, and then I can integrate them just by using the service name. So if this application wants to communicate with this particular MySQL application, all it needs to do is use this name. Okay, so this is like an internal service discovery for the platform. All the service discovery happens using the service names. Okay, so if this application wants to communicate with MySQL here, all it needs to do is refer the host name of this particular application as MySQL. That's it. Or if you have some other custom name, use that name. It's as easy as that. And also, for your applications, you can also look at the logs, like what exactly is going on inside your application. So it's pretty easy to look at logs. And the other thing that OpenShift adds on top of Kubernetes is, if you want to look at the archive of this application, so you may have scaled it up and then you may have scaled it down, but where do all those logs will be stored? So OpenShift gives you an inbuilt logging based on Elastic, Fluentd, and then Kibana. So all the logs are basically persisted inside your OpenShift cluster. So you can see the archived logs for that application, or the live logs, are basically stored inside a Cassandra database and then shown it here. I mean, I think looks like I did not configure it properly, but if you have the right one, it basically shows all the logs inside this particular Kibana interface. Okay. So your logging is addressed. You can basically have a UI to interact, and then a different kind of storages on top of Kubernetes. And then also monitoring is another important piece. If you click on monitoring, it will show you all the events that are happening inside this dev cluster. So looks like something is not healthy, pod creation, pulling, like all these events are basically captured inside the monitoring section. Okay. So I will look for one more time for questions. If we don't have any, I'll go show you how to set up a pipeline. So Yuri, I think the issue is on the firewall side, which is on Google, not on OpenShift side. Like your OpenShift cluster should be able to talk to GitHub. I think it looks like when it is talking to GitHub, it is not able to, like, the firewall is restricting that connection. And then looking at the security side, which Shyam asked, so definitely OpenShift adds a lot of security features on top of Kubernetes to make it like enterprise ready. If you have looked at RBAC controllers, the recent 1.6 version has RBAC controllers, right? But in OpenShift, they were there from the beginning. Okay, so the multi-tenant features that you see are basically came from the origin development, and basically RBAC controllers are there in OpenShift from long time. And then not just those, but what OpenShift does is basically enables SE Linux by default, and also manages all the SE Linux labels for you. Okay, so your containers are secured by your SE Linux rules on the host operating system, so which makes them more secure than the traditional, like on top of whatever you have in Kubernetes. You basically SE Linux like labels all basically adds more security on top of it. And then OpenShift adds features like not just OpenShift, it also there in the Kubernetes, the service accounts, which basically enable you to run applications with different kinds of privileges. So you can restrict, like you can have fine-grained control on what kind of capabilities your containers can have. Okay, so you can basically choose kernel capabilities level permissions on each of these applications to be able to run your containers pretty securely. Okay, but otherwise, on top of Kubernetes, OpenShift is also having like many other security features, like I said, RBAC, and then it has integrations with LDAP, most of the like OAuth systems, and AD. So all other syncing with those authentication systems are also in place. As far as the like low-level security is concerned, I think SE Linux management labels is pretty big feature as far as OpenShift is concerned. And there is a whole different section on security. I'm not really an expert on the security side, but I remember there's a white paper published on making like running secure containers securely using OpenShift. So that deals with a lot of additional features that OpenShift adds as far as the container security is concerned. I would Google it if it is possible. I'll try to locate it, but I think it's pretty easy to locate on Google as well. So how can you tell how much node capacity you have available? So if you have looked at Manage IQ, Manage IQ is like another open source project which has like native integrations with OpenShift. So the Manage IQ basically talks to OpenShift over API and then gets all the metrics related information. So how much your node is using, how much your pod is using, like all these details you can basically pull over the OpenShift API and then show it inside Manage IQ console. So the integration is pretty easy. Like I said, it's just over API. You just need to supply token and then it will pull everything, all the metrics, and then show you there. But otherwise, OpenShift itself will don't deal only with the application metrics. For the platform metrics, there are facilities to see if you type node and then put the node name there, and then that shows you how much utilization you have on that particular machine. But if you want to see a graphical interface, I would suggest you to look at Manage IQ or Cockpit project, and that's another one, but totally possible. Okay. Cool. So if we are good, I'm going to show you quickly how we can set up a pipeline for the project. Like you can deploy a CI/CD like Jenkins instance. I'm going to create a CI/CD namespace and then show you how we can deploy Jenkins and then integrate with OpenShift. So click on continuous integration and then click on Jenkins formula persistent and then deploy this. So OpenShift will basically run Jenkins as a container inside OpenShift, and this Jenkins can talk to all the other projects and basically do the activities like moving your application from dev to QA or QA to production, and you can also have the all kinds of rules in place. So it's pretty easy to do that. I'm going to do it quickly. OpenShift, if we go to OpenShift example on my GitHub page, it will show you there is a pipeline example. I need some permissions to be given for Jenkins to be able to pull images from dev. So I'm going to give those permissions. This is just for telling like Jenkins should be able to pull from dev and proj Q namespaces. Okay. And after that, I'm going to create the pipeline. The pipeline object, I'll show it in a second. Let me create that first. So you can see the pipeline object is basically pretty simple Jenkins 2.0 syntax. It says there is a different stages like build in development, apply in development. You can do some QA as well. You can do some code quality analysis as well. And then deploy in QA. Before you deploy to QA, ask for permission. So all these you can basically do it inside your different stages. The rest all you can ignore. This is just for like the OpenShift to understand this pipeline, but the important thing is here. Okay, so it should be good enough to set up a pipeline. Now if I go to QA, if I want to do it manually without Jenkins, I can just go to add to project and then click on deploy image and select the developer namespace. Like Dev said, this is my namespace and this is the application name and this is the version. I can select that and then hit create. Okay, so this is like a simplest process without doing any much like code quality and all those things. If you want to just pull the image and then test it, This is like a simplest process. So you can see I have deployed the welcome applications that is created by dev onto a QA namespace. So pretty quickly you can move from dev to QA within minutes. Okay, I have my QA application now, and then I'll get a QA specific URL which I can test. Okay, that is one aspect of it. But if you want to do some advanced CI/CD process where you do some like checks, integration tests, and all those pieces, you can use Jenkins for that. Okay, so I have my Jenkins instance here. You can see if I go into log section, Jenkins is booting up. Once that boot is complete, all we need to do is go and look at the pipeline that we have created. So in the pipeline, go to builds and then pipeline. Click on the pipeline that you created a few minutes ago. Like this pipeline I've created using the CLI, like this command. So it is there here. And then once the Jenkins is up, all you need to do is click on the start pipeline to be able to do all the activities that I've mentioned in these stages. Okay, I'll give it a few seconds. So node capacity, it has a Kubernetes. How can we compare OS platform with Microsoft Azure or IBM Bluemix? So this particular OpenShift container platform is running on AWS now, but it can run on pretty much any IaaS provider. All you need to have is Linux operating systems. But otherwise, there is no hard dependency that it will only run on Windows, or like only run on VM, or only run on this particular IaaS provider. So it can run on Azure, Google Cloud, AWS, VM, bare metal, you name it. Okay, all it needs is basically a Linux operating system environment. That's it. So once we have the pipeline, you can just kick off this pipeline. You can see it talks to Jenkins that we deployed, and then does all the activities that we mentioned in the pipeline. So it is doing a build in development, and then after that it does a deploy in development, and then after that it goes and deploys in QA. Okay, that while that is progressing, you can ask if you have any questions. So the primary difference I want to mention here is, like, if you're using just Kubernetes, not OpenShift, you are actually building all this tooling around Kubernetes to make it enterprise ready. So someone said, I can point to, I'm not really taking the name, but you take Kubernetes, you do a lot of tooling around Kubernetes, and then you will end up something like OpenShift. So then why not just use OpenShift in the first place? So that's what my opinion is. It may be different for others, but that's what I feel. Because all these things that you see, whether it is pipelines or RBAC that you see, like recently Kubernetes also added RBAC, but a lot of features that you see are already there inside OpenShift. So why not just go with that? And like I said, I'm doing like for a community event only. I'm not doing anything specific to Red Hat here. It's just as a user of OpenShift Origin, that's what I feel. So that's one aspect of it. And then this is truly adding like a lot of developer features on top of Kubernetes. So when you think of Kubernetes, is more looks like Opsy, but OpenShift is like a bridge for Kubernetes, basically taking care of the developer aspects as well. Now we can see the build in development is complete, and now it is deploying in development. And once that is done, it is going to deploy it in QA. So if you go to developer namespace, you can actually see that the deployment is happening here. Okay, so this is really doing all the activities that are mentioned inside the pipeline. Okay, so that basically mostly concludes my demo. But if you have any questions, I would encourage you to follow me on the Twitter and then ask questions there. It's totally I'm available most of the time. So is twitter.com/debianmaster. So feel free to post any of your questions. And then the channel itself, I'm trying to keep it very active. So look out for the YouTube channel for more content. I'll be posting frequently there as well. So now it is, before deploying it to QA, it is asking for input, like to approve. If I go click on this, it's really going to Jenkins, and then I can approve there. Okay. I hope I remember. Oh, okay, I don't remember the password, but I can go and approve there, and then it deploys in QA. Okay, it's pretty obvious. So, any other questions? I hope this is useful. In future, I'm planning more sessions, like slightly advanced than this. But feel free to suggest any topics that you have interested in. You can suggest it on Twitter or maybe on the meetup group that we have. All right, so looks like everyone is good. And if no one has any questions, I'm gonna call it a day, and then see you next time. Thanks everyone for joining.